So while I was thinking about what I wanted to do for my mechatronics project, I was driving down the road one day and I noticed I was fiddling a lot with the knobs, like the temperature knobs. It was either too hot or too cold, and I kept changing it constantly. And I thought, what if I could have some sort of system where I input a temperature and have the car adjust to that temperature for me, kind of like a thermostat in your home, but for the car. So throughout the semester, we've been prototyping and working with Arduino Unos. Now, for my project, I decided to work with the Arduino Nano, which is about a fourth of that size. The reason I did this was one, well, it's more compact, but another advantage to it is that it's very solder friendly. All of the circuitry is soldered together on proto boards like these. So there's not a single breadboard in the system. So it's a lot more solid. It won't come apart with the vibrations from the car or anything like that. So this project is plugged into a main board that I soldered together. It consists of an Arduino Nano, an ADS1115, and a buzzer that's soldered next to it, and just some 5-volt and ground pins for wiring. And next to the main board, I plugged in my temperature sensor, which is soldered onto a board like this, and it just consists of a thermistor, a 10 kilo ohm resistor, and a power, ground, and analog pin. And with all that, let me show you how it works. All right, so here's the completed project. One feature I do want to show you is that earlier I was running the system, and so the knobs are in different positions. They're not in their starting positions. And so on the Arduino, you're able to use, it's called the EEPROM, and you can store data onto memory in the Arduino. And so the Arduino keeps track of what positions these motors were in, so that when I start the system, it should reset back to its original position, even though right now it's completely off. And there you go, it's back in position 1. There's a lot of different components that make this system work. So we have the LCD screen right here, which displays the current temperature and the desired temperature from the user. Moving the joystick left and right changes the temperature to the next multiple of 5. We have the main control box with the Arduino Nano and the temperature sensor, the thermistor sticking out of the hole right there. We have the 2 motors controlling the flow knob and the temperature knob. And one thing to note is that the big stepper motor is running on this motor driver right here, and the driver for this motor is mounted underneath. Also, one thing I forgot to note, there is a plug here for uploading code, but as you'll notice, it's not plugged in. This whole system runs on one plug, and that's all thanks to this little buck converter here that takes the 14 volts from the car and steps it down to 5 for the Arduino. Let's just see how it works. I'll input a temperature I want. I'm feeling like 70 degrees Fahrenheit. And once I hit go, the temperature knobs will start adjusting and trying to get to that temperature. So as you can see, it's turned up the flow rate, and it'll start adjusting hotter and hotter until we eventually reach that nice sweet spot at 70 degrees Fahrenheit. All right, so as you can see, we're right around 70 degrees Fahrenheit, and so it's turned down the flow just a little bit to be less aggressive. But yeah, so it'll stay around 70 degrees Fahrenheit like I told it to, give or take about 1 or 2 degrees. And let's say I'm actually feeling like a colder temperature. Well, I can simply change it to, I don't know, let's say 55 degrees, and it'll start changing the knobs. Oh, sorry, we're out of focus. There we go. So now it understands that the error is a lot bigger, so it changes the temperature more aggressively by turning up that flow knob, and it'll start cranking the temperature colder and colder until we get to 55 degrees Fahrenheit. And yeah, that's how it works. And that is my mechatronics project. I learned a lot while building this. I ran into a lot of problems during development, and it put my problem solving skills to the test. But I really enjoyed building this, and it helped me learn a lot about how to design a project and make it happen.